He's here.
All right. I'm not sure if you can hear me. Can you hear me? Just want to make sure.
Yes, sir.
Yes, sir.
Okay, great. So we are going to continue off from where we left off. And we're almost done with lecture series number 12, which was the plan actually to make sure that at least halfway through the week we conclude. Give me a second here. I'm trying to see if we can. Do a sort of like demo here, but I don't think it's going to. The thing that failed to work the other time. Not really the thing that failed to work, but I was hoping we could do a demo of trying to exemplify exactly what happens when you attempt to copy across a file, a relatively large file that goes beyond the maximum threshold associated with a particular file system. And I'd actually initially planned to hunt for that huge file that I have. And I could have sworn I had it somewhere on one of my external hard disks, but it appears I do not have it there. It's a bit unfortunate, really, but very, very unfortunate, actually. I thought I could showcase that, but anyway, doesn't look like it's going to work anyway, but right, so as I'm hunting for the file, any questions with regards to what we looked at as of the last time we met? Okay, if there are no questions, then we proceed. Can't seem to find that file. But you want to try this out on your own, and some of the things that you find. Yes,
sir. Can't see. Oh, your screen is now on, and I couldn't see your screen.
Yeah. Well, so for some of these things, the things that you're going to be seeing in the slides, at least the illustrations that we're not really going to demonstrate, like during this lecture series, you probably want to do this on your own, right? You try them out and just try and explore and see what happens, right? Turns out this is how you learn. This is unlike these other courses that you're doing where all you have to do is, if there's a test, all you have to do is read some, I don't know if it's some essay or something, and then you're good to go, right? It's okay. No, it doesn't work like that. It turns out that for you to be able to complement these things that we're talking about, you want to experiment with these things. And in fact, it's, who is this? I don't know why people say, sorry about that. Sorry about the phone, right? So, what was I saying? Yeah, I don't know. There's a reason why we keep on making reference to things like, oh, Android, because we understand that the vast majority of you have access to an Android-powered device, making it extremely easy for you to be able to experiment with your Android device, right? Do you understand this? Most of these things that we are talking about, most of the things that we are going to continue talking about can be done on Android, right? Can be done on Android, right? And I know in one of the lab sessions, I probably introduced this whole notion of the Android debug bridge or something. Although those are really, we skipped it, which is not really like you were meant to look at that, but I thought would throw it in to give an opportunity to those who might be interested in exploring a bit further to look into it. It turns out, right, that, well, we did discuss this, your average smartphone is a microcomputer anyways, but it turns out, I observe, I'm just going to do a couple of things here, right? First, I'm just going to showcase, this idea of Android debug bridge here. I'll connect my phone, right, using ADB. And then I have access to everything. So the case study that we're going to look at in this lecture series, right, where we start talking about the different locations on your typical Unix-like operating system, they apply to Android, because Android is a fork. It's a Unix-like operating system, right? So this thing will come up a lot. You notice I'm currently I'm currently in the root folder, right? I'll probably go into, I could go into my SD card and then be able to access movies and, well, I don't have movies, but as in footage from my Instagram anyways. But the other thing, right? The other thing is, because you can only use Android Debug Bridge if you connect your mobile device, your smartphone, using the USB port, right? And then you obviously connect to it using ADB, right? So you can run a number of nifty commands, right? Same commands that Lighton normally runs when showcasing some of these examples, but it gets even better, right? You can install really interesting application software
Sir, you are blinking.
So you're breaking.
I am breaking for now.
Samo point.
Sir, we can hardly get you.
Sir, you're breaking.
and that would go.
This man is breaking for real.
Point.
I do apologize for that break in transmission. Zambia, right? I mean, we have no power at home, and so I think my routers have run out of power, right? And so I'm tethering my phone, and the person called, and such a sad life. Okay, so I was just saying, right, that it turns out that on your Android-powered device, what you can do, right, is for you to be able to experiment with some of these things. What you can do is you can play around with certain applications. Can you hear me, by the way?
Oh, yes, sir.
Oh,
Yes.
Yes, sir.
Yes,
thank you
sir.
very much. You can play around with certain types of applications. Now, I just showcased to you how you get to use Android Debug Bridge. But Android Debug Bridge only works, or it will only be able to work if you have a computer, right? So ideally, the idea behind Android Debug Bridge is you interact with your smartphone via it could be your laptop or your desktop computer, for instance, right? Very, very useful, especially when you get to a stage where you start learning how to, I guess you are going to be taught this, I don't know, right? I think so, in 2010, where you get to start writing, is it mobile applications or something, right? And it turns out that it's a lot easier for you to test using an already existing device. Now, granted, there are emulators that are available, right? Application software tools also. So the emulators that you can use, but sometimes you want to test things on a real device so that you have a feel of how exactly your application is going to behave as users are interacting with it, right? In a somewhat authentic setting, right? So this is one of the reasons why Android Debug Bridge becomes really useful. But also, if you're a power user, right? If you're a power user, there are certain interesting things that you can do. So instead of me connecting my phone and then treating it as a mass storage device, telling my computer this is a mass storage device, and then I start double clicking using my file manager, what I can do is, if I know where things I'm looking for are located, just go there, right? Go here, and I don't know how much space I have left here, but I'll go, oh, it's not a lot. I'll go here and I'll use, I guess we'll go into, I'll use Android Debug Bridge to just pull whatever it is I want, right? Example, ADB example, something. And just pull whatever it is I want. And I just pull everything, right? Just get everything, and then I let it run in the background, right? I'll pull the files that I want, right? So it turns out for power users, this is a very useful thing. But if you want to be able to follow along with some of the things that we are going to be looking at going forward, I suppose, seeing as Unix is used as a, or Linux is used as a case example, what you can do is you can install certain types of application software tools. For instance, I'm just going to stop sharing my screen, and then I will share I will connect I'll share my smartphone screen, right? So that I showcase to you what exactly I mean. So I'm going to open up, it's gone now. Wow. I'm going to open up Meet application. That, just give me a second, and audio off, join. Yeah, we know it's being recorded. Okay. All right, so yeah, Lighton just joined, right? So I'll share my screen. What I mean is there are certain applications, and I do encourage you, if you have an Android-powered device, please, and this is by all means not the only application, as we know by now. This happens to be just one of those applications that you might want to look into. Lighton has used this for quite some time now. It's called Temax, right? So with an application like Temax, I can literally interact with my, come on, Temax. I can interact with my device just as I do on my computer. I'd be able to run Unix commands on my computer, right? So I can, I can do an ls, right? Press enter. I don't know if you can see that. I do an ls, press enter. I can see what's there. I can do a pwd, right? I can run nifty command like ps to check, not pw, but ps, check the processes that are there. I can run things like who, right? Who is w, I suppose, not who. Okay, w, I suppose. Who is not recognized there. Right, so looks like a lot of things are not being recognized here. But anyways, I can do cd and then get into root or something, right? So you can literally run Unix commands on your what are you doing here? On your smartphone, right? So I do encourage you to look into this. It's an application called Temax, really nice. You can literally install different sort of things, right? Applications that you'd otherwise, I guess, things that you think you might have thought can only be installed on a laptop, for instance. You can do this on your phone as well, right? And be able to just, I guess, play along or experiment with some of these things that that we're going to be talking about going forward, right? Okay, so I'm just going to unshare my screen and then disconnect here so that we continue our conversation. All right. So we did quite a bit, right? We looked at file systems, and then we ended our conversation on so-called file managers, and we discovered that they're quite useful when it comes to users interacting with the file system, right? It's a gateway to gaining access to one of the core features or functionalities of our operating system, file management, right? So we get to use file managers for us to perform all those different file operations that we talked about. If we want to edit files, if we want to delete files, if we want to rename files, if we want to create new files, right? And of course, there are auxiliary features associated with file managers, right? It's quite good stuff. So we start our conversation of a Unix file system, I guess to showcase exactly like an implementation, right? An example implementation of the file system and how things are actually linked together. Now, our discussion of this case study is normally restricted to the folder hierarchical structure so that we get a sense of important locations on your typical Unix file system, so that when you, let's say, use Android debug bridge, and you are in here, for instance, you know exactly, I wonder where this is, you know exactly what MNT is, right? The mount point, for instance. You know exactly what is in the bin directory, right? Usually binary files executables, really. All right, so this slide just shows you a visual representation of hierarchical structures associated with Unix like file system. If you remember from the time we started talking about file organization and file systems, I kept on mentioning that for Unix-like operating systems, or for the Unix file system, the root is always a // right? This is the beginning of everything. This is where everything begins. So all the different directories and files are located somewhere on the Unix file system relative to this root path, right, which is your // So everything from, in fact, pretty much everything is treated as a file in Unix, right? So mount points, for instance, if I connect a USB disk to my computer, I'll typically gain access to it via MNT or media. In certain variations of Unix-like file systems, you have media as opposed to mount point, right? So different sort of things here. And it turns out that there are conventions that are followed with regards to what you typically expect to find in these things, right? Rules. And they're there to enable you be able to install things in the correct location once you start installing things. So just to kind of mention here that that these so-called Unix-like operating systems have actually, there's different variations and they've evolved over time, right? So over the last couple of decades, we've seen different types of Unix-like operating systems, different breeds, and you can actually trace the family tree by just going to Wikipedia. There's a very nice tree, a family tree of the Unix-like operating system, beginning with the first version of Unix, right? So you can see, I don't know if there's Android somewhere here. You can literally trace the family tree here down to things like the Mac OS, for instance. So if you're one of those people with money and you have the Mac or an app, I don't know if I call them Apple machines or something, you notice that it's a Unix-like operating system. So you can run pretty much the same commands that Light one has been running, right? Linux is also a Unix-like operating system, right? See here, and in fact, there's different subcategories of Linux, right? So Red Hat, things like Ubuntu, Debian, right? Different variations. But anyway, so it turns out that whilst you have these different, in fact, maybe we can just look at it here so that I can share this with you. Unix like OS. You probably want to go and visit this, by the way, the page. Maybe just kind of read up on the history of Unix, right? Evolution. This is interesting. I've never come across this type of visual. This is even better, actually. Pretty nice. I'll share this with you. It's an SVG file. I encourage you to look into this. If you want to get an appreciation. Somewhere here you should be able to see Android, I guess. I don't know if it's there. No, this tree is not, it's not here. But anyway, so different variations out there. But it turns out that one of the things that they have in common is your typical file system, right? So the structure is pretty much the same, irrespective of whether you're dealing with FreeBSD, if you're dealing with Debian, Ubuntu. Usually minor differences, like you might have some variations that might not have directories named in a certain way because they use a separate type of convention, but the idea is pretty much the same. Literally all of them will have a home directory, right? Where you have directories associated for the different users that have been created on that particular system, right? Right, so on a Unix file system, every file has a path name, obviously, right? It's always relative to something, and this is tied to this notion we introduced last time we met when we were talking about, is it the day before something, we're talking about relative paths and absolute paths. So every file will have a path, right? And that path will indicate, its structural metadata associated with where on the file system is actually located. So you can notice here that this file path here is associated with the directory slides, right? Directory slides here. The highest level is obviously the root, which is the /. It's a parent of all the directories on the Unix file system, right? And also, interestingly enough, your different directories, your container structures associated with any given file on the Unix file system are separated by the /, right? So compare and contrast with Windows, where I think it's a / or something. So what we're saying is, if you have a file that is located in, say, some funny location like Dropbox and documents and work, like in here, what we're saying is the file path, this thing here, is composed of directories and subdirectories that are separated by the /, right? This character here, this is the file separator. On Windows, I believe it's a /, so you have funny things like users or something, or download, users, I don't know if you get downloads or the documents or whatever, I don't know, right? But on Unix, it's the file separator is the /, right? The root on your Windows will typically be the drive, a letter representing the drive, followed by the full colon, right? So this will be your root. But on a Unix file system, the root would be just a /, right? This is the parent of everything. So everything is relative to the root, essentially. All right, so just I guess it's just a short walkthrough of some of these common directories associated with the file system. So home contains files that belong to system users associated with that particular operating system. So if you were to install Ubuntu, for instance, for the first time, remember in one of the labs we did, you had to create a user, right? What we're saying is that once you create that user, the username is going to be nested within the home directory. So once you create that user, what will happen is in this location here, which is /home, you will have the name of the user that you've created, right? And then it is within here that a user will start, getting access to things like downloads. So when you download something, it will be, by default, it's dumped into home, your username, and then downloads, right? If you're creating a document in a default location, which is documents folder, it will be /home, your username, and then documents, right? Observe, if you look at Lighton's computer, for instance, I'll go to the root. This is what we're talking about here. Maybe do a tree so that you see what's happening. Oh, level 1. have one, right? So this is a structure we're talking about here. What we're saying is that all of the users, the users on this computer that Lighton is using right now, their system files are going to be in the home directory. So if I go in home, I will have all the users. So Lighton clearly has Lighton's computer has 1, 2, 3, 4, 5 system users, right? Now, granted, there's certain special users that are created by default as you're installing the application that won't have corresponding home directories created. But these are users that were explicitly created. Like, so for instance, right now I'm logged in as Lighton, right? So all of my system files are in this directory here. If I log in as this username, the files are going to be in that funny name here, right? So you notice I have things like desktop, I have documents, I have downloads, music. These are default things that are created, videos, pictures, yeah. So that when I get screenshots of, let me just go to home here. If I go to home and then I go to pictures, every time I take a screenshot, right? Every time I take a screenshot, this thing once saved, I guess we just say save. Once saved is going to be in pictures by default, right? So similar things that kind of happen, you notice 1727. Similar things that kind of happen when you are downloading things by default, it always goes into the downloads folder, right? So if I start downloading a file, if I download a file right now, maybe we can do a watch, I suppose. If I was to, right now it's what I have here, but if I was to start downloading some funny file somewhere, right? Let's say, I don't know what I'm going to download here, but not illegal movies because we're recording this, but let's say I want to go to, the UNZA, right? The UNZA website, and then maybe I'm probably going to find something interesting. Publication, there's intake, right? I go here and I want to see, yes, I want to see how many smart people are going to join us in our thing, right? Smarter crop of students that are going to join us next year. I would go to information and communication technologies, and then male or female, I don't know, maybe female, right? And then if I say I want to download this, by default, once I download this, well, this thing, obviously it's not going there by default, but ideally it's supposed to go into the downloads folder, right? And then you find it in here and you'll be able to see it somewhere here or something once it's downloaded, right? Anyway, easy stuff. I wonder how many people are coming through next year, Bachelor of Information and Tech. It's 17. Wow. This is not right. What's happening? Anyways, is this making sense?
Yes, sir.
Yes.
Good stuff. I'm wondering what's happening here. Information. Maybe they have two lists, right? Why do they have two lists here? No. And they have 6. Okay, it's up there.
One is for the female, the other one is for the male.
Yeah, but this is not normal. Why do we have 55 for males, right? No, I think something wrong here. I think it's like kind of, this is what we're looking for, I guess. Don't know. Wow, that's enrollment here. All right, good stuff. I hope this is making sense, right? Home direct, let's not lose track of why we're here. We're not here to look at the list of smart students that are coming through next year. People are smarter than you are, obviously, but we are here to talk about the Unix file system, which is good, right? So what else is there? There's bin directory, right? It's short for binary, right? So, and typically binary files are normally associated with executables on the Unix-like operating system. So the vast majority of executable files, so the commands that you typically run when you're on a Unix-like operating system, especially if you're using the terminal, would typically be located in your bin directory. Observe, if I say which ls, yeah? ls is in the bin directory. Do you understand this? If I do a file on ls here, notice that it's an executable file, right? So ls, when I run the command ls, it's actually the executable itself. The program is in the bin directory because it's an executable, it's a binary file. I know I would say everything is binary on a computer, yeah, but in this case, it's we're saying executable files, right? So most of the, in fact, the vast majority of these applications that you run on the terminal, like PWD, for instance, present working directory, if I check where it's located, PWD, it's in the bin directory. I don't know if you can see my screen here, bin directory. Funny thing is, if I check where which is, I would say which, okay, which is in, like, it's in the bin directory, but for the user, right? So user bin, right? So anyway, the bin directory will typically have executable files, right? That are accessible by all users, essentially. So anything to do with devices is in the dev directory, right? You can play around. You can play around with some of the things that are in here. So access to terminal, the different terminals associated with your operating system. For instance, what interesting thing can we do here? Can we check for? So if you notice that the interesting thing about Unix is that everything is dealt as is viewed as a file, right? So if you look at this thing, current CD-ROM drive here, it's symbolically quite all right, but it's ideally supposed to be, it's a pointer to a device, right? But as far as the Unix operating system is concerned, it's a file, essentially, right? Anyways, so devices are found in the dev, right? The lib directory will typically comprise of software libraries, right? Software libraries that might be beneficial for the vast majority of applications that are installed, right? The etc directory will normally have just basic system configuration files. The MNT is nothing more than a mount point. This is where you mount your devices. Traditionally, right? MNT is just short for mount point. Traditionally, you typically mount things on MNT, but these days, alas, things have changed, right? So if I was to plug in, my goodness, if I was to plug in, I wanted to plug in something here, but looks like we won't be able to do that. If I was to plug in one of my external disks, what you will notice when I plug it in is it's not necessarily going to be mounted on MNT, but I'll get access to it on the I'll get access to it on the media, under media, right? Observe, if I say I want to open this device here, what you will notice immediately is that if I do a DF here, it's actually mounted under media, right? So I have access to this. I have access to the external hard disk that I've just hard drive that I've just hooked up to my computer via the media directory relative to the root here. But traditionally, things have pretty much been mounted on MNT really. So I think I've mounted. Oh, I haven't. I think I've mounted a couple of things here, by the way, in the past. Looks like I've been doing some strange things here. So in an ideal case, I shouldn't have been mounting some of these things under the media. I should have, it's just convention, you know, I should have been doing it under MNT, right? So some of these things you're seeing here, these are permanent mount points. Like this is a pointer to, I believe it's to an FTP server or something, right? So it's a storage location, a remote storage location that I mount onto my computer, right? And I access it as I would any normal folder on my computer, right? But it's a remote folder essentially, remote location. Anyhow, and then the proc directory is related to system processes, right? TMP is for it's a location for temporal files. So if you are installing some piece of software, normally what will happen is some files will be temporarily located into the TMP file. And then once you reboot, everything is wiped clean, unless if you change the configuration such that these things that are in the TMP directory are kind of like, and I just did sudo here, they remain persistent, right? You notice it's pretty, this isn't really a lot here, the size, 164 kilobytes. Anyways. Right, so USR, or the user directory, also contains additional executables. So this complements what you'd find in the bin directory. And you notice this when I was checking for where which was located. You notice that as opposed to where ls and pw are located, you notice that which is located in a bin directory that's relative to user directory here. There are also some applications that you find in sbin, I suppose, right? So anyways, and then the root folder is reserved for the entity. Yes, sir.
What's the difference between the bin located relative to the user directory and the bin located relative to the root file system itself?
Well, I mean, I suppose in one instance, maybe all of the, I could be wrong here. So the bin directory will typically contain required or mandatory executable files, right? So these are applications that would normally be essential to the average user, right? And then the user bin would comprise of things that are not necessarily required. That's when I was looking at this, like which, for instance, and ls. You know, you need ls, right? You need to find your way around. I could be wrong here, but one of them contains mandatory executable files. One of them doesn't.
All right, sir.
I think should be the case. Yeah, should be the case, I guess. I don't know. Yeah, I think it has something to do with this. You want to look into that, right? But there's a neat way of checking this. Let's just see what's in here, right? If you look at some of these executables that are in here, right? Zip, zeal, you know, these are not like essential things here, right? Yeah, Quake. So some of these things are actually things that I explicitly installed myself, right? Because they're auxiliary binaries or binary files. But if you look at what's in the bin directory, what you will notice is that these are essential files, right? So things like grep, for instance, you need grep, you need ls, you need echo, right? So yeah, I think we're on the right track by saying slash bin will comprise of essential binaries, required binaries, and then the other one will contain the non-essentials, essentially. No pun intended. Okay, and then the root is just a home directory for the power user, right? So just like you have that administrator account on Windows that you use to create other accounts, that you use to do to perform important operations, right? That require special permissions. The same thing is applicable for Unix-like operating systems, right? So you typically have a root user. And the root user's home directory is not located under /home, right? By default, you'll find it under /root. This is where you find the root user's directory. And you notice when I attempt to get into root here, I'll probably have to do an SU here for me to be able to get into the root folder here, right? And then I'll be able to get into root or something, and then, you know, I have access to some nifty things here. But anyways, yeah, so I already mentioned here that one of the interesting things about the Unix-like operating system or Unix file system or Unix operating system is that everything is treated like a file, right? Including devices and disks. So every time you mount a disk or your remote storage location, the operating system will view that as a file, right? Very powerful here. Okay. So I guess enough about the typical structure of your Unix-like your Unix file system, right? The thing here is that everything is relative to the root, which is a /. There are certain directories that play special roles, right? They serve a specific function. Suffice to say that most of these things are just done by convention, right? So if you want, for instance, when you're installing software, what people will tell you is that if you go online and you follow through instructions, what they'll tell you is that you must install software under the OPT, right? Under opt. This is where you're supposed to install applications. But it's not set in stone. What you can do is you can decide to install this software elsewhere. And I've done this myself, right? There are certain pieces of software that I've installed under my home directory, for instance, like DSpace, right? It's under home, right? But sometimes it's important to follow convention because who knows, maybe somebody else down the line might want to gain access to whatever system you set up. And so it's a lot easier for them to be able to trace your footsteps if you follow the rules, convention. Right? I don't know if you're getting this subtle idea that I'm trying to push to you here. The fact that typically server-based computer systems are the ones that are normally associated with Unix-like operating systems. When you're working with servers, it's usually in large organizations like the UNZA, right? Where people's presence is transient, right? They're not there permanently. Here today, not there tomorrow, you find something else better to do. If you were involved in setting up some application on some server computer system, the person coming to replace you will be able to figure out what it is you did if you followed the rules, convention, right? Anyway, don't just do things randomly. Great. So I guess now will be a time to just briefly talk about so-called permissions in the Unix file system. Right? Technically speaking, permissions are represented using numeric digits, right? And these numeric digits play some special role, right? So depending on the number that you associate to each one of these three placeholders here, you get to determine exactly what sort of permissions you're going to associate to a file on the file system, right? And typically this number here is linked to 3 entities here. It'll be like the user, the group, and everybody else on the operating system. So given a file on a Unix-like operating system, you specify permissions relative to the owner of the file, the group associated with that particular owner of the file, and everybody else on your file system. You see this here? Permissions associated with the owner, the group, and everybody else on the computer itself, right? And what you're doing as you're changing these things here is you're playing around with these values we're talking about here, placeholders here, right? And we explain exactly what these mean, well, the importance of these things just now. So if you're using the terminal, this is what you typically see, right? Each placeholder to see if I can. I don't know if you can see this here. If I do an ls using long form for the file that we just downloaded for the new kids that are coming through next year, new toys, you'll notice that this is what we're talking about here, right? Owner of the file, group, and everybody else, right? This is how you specify permissions. This is representative of what you're seeing here. Right, so you have the file owner, the file owner's group, right, and everybody else on the system. The file owner is the person who created that file, or the person who has been given or granted ownership to the file, because it turns out that somebody else can create a file, but then you can change ownership, right? You just change the metadata essentially. The group is the user group that the user belongs to. Just like Windows, on Unix, you can also create different groups. One of the reasons you might want to create different groups on an operating system is so that you can selectively assign permissions to groups rather than individual users. Think about this for a second. You have a server computer system like the one we have in the audio laboratory, right? I don't know if you ever got the chance to use the lab here prior to COVID-19 here, but we have those dumb terminals, right? In the lab, and use the dumb terminals to connect to a server, right? So all the dumb terminals essentially, well, the dumb terminals are used by students when they're in the lab, but the dumb terminals don't have dedicated system units. Rather, what students do is they connect to a server computer system. Now there's something interesting there. The fact that what you would ideally want is to ensure that you create different user accounts for different students that have been granted access to that server. So every year you have a crop of students come in, you create user accounts for those students. Those user accounts are being created on the server computer system. Because you're creating a bunch of users, hundreds of users effectively, right? In any given, in fact, by next year, we will have a group of students, first years, second years, third years, and fourth years. What we might decide to do is to say, because fourth years know exactly what they're doing, we can grant them slightly higher permission so that they can do more sophisticated things than first years, who are mostly just interacting with the computers via trial and error. Now there's something interesting here. Rather than assign permissions to individual students, like we currently have almost 87 students enrolled into the course, right? Instead of creating permissions or associating permissions to all the 87 user accounts, what you can do is you can just create a group to say first years, another group second years, another group third years, another group fourth years. And then what you do is when you're creating user accounts for the first years, you assign them to the first year group. And then what you're doing is you just modify the permissions via the group itself. It's a really nifty trick, cheap trick, really, but it works all the time, right? So anyway, so essentially what we're saying here, when you do an ls, for instance, what you see here, these letters RW and the hyphens here represent read, write. Sometimes there's execute, right? Read, write, execute, read, write. Hyphen, the hyphen means there's no permission associated with that placeholder, right? So you have the permissions, and then I don't know why it's saying link here. I have to look into link. I don't know what this is interesting. I don't know what the link, I've forgotten what the link is. Maybe if we check, go to Dropbox, I guess, and then check folders. Maybe folders will have a different, wow. Yeah, I'd have to look into what link is all about, but you notice that there are different numbers associated with, I guess for folders, it means the number of things that are in there, right? So if I go in personal, no, it doesn't. No. Anyway, something to look at, right? So this table is just showcasing what is represented by these different placeholders here. So you have permissions here, right? RW, read, write, hyphen is nothing. And then link, and then you have ownership relative to the username who owns that file and the group which they belong to. And then you have the size and then the date stamp here. And then finally the file name, right? I think you remember the file name, we had the discussion of the file name here. What you notice here, right, is that all of these things here are metadata elements, right? And we discussed most of these metadata elements here, the size, the timestamp or the date, the file name, and the permissions. And so typically access to the file is dictated by so-called user privileges, right, that you associate to the file. Key thing here to note is that every time you see a hyphen, like this is on the terminal, right, it means that no permission has been assigned. R means read, W means write, X means execute, right? So if I was to go into a location, I think I have an executable file here, and do an ls for Postman, I know that Postman will have an X, right? This is an executable file. So I know that I can execute this file because I can see that there's an X here for everybody actually. So the user, the group, and everybody else in the system can actually execute this file. And it makes sense because Postman is nothing more than it's a binary file. It's an application software. Desktop application software, by the way. right? Anyways. Is this making sense? Are you even there?
Yes, sir.
I wonder.
Yes.
Okay. Yeah, I thought it was making sense also. I guess, but then I've been teaching this for the last 2 years, the third year, so. Oh, wow. This is, man. I'm trying to think if there's a, oh, sorry about that. I'm trying to see if there can be like some simulator we can find online for you so that you start practicing some of these things, right? Because in as much as, in as much as like, so you notice that there's typically a total of 9 variables associated with permissions, right? So and it makes sense, right? Because each remember we're saying permissions are relative from the owner, the group, and everybody else in the system. So we're saying we have the owner, the group, and everybody else in the system. Owner, group, and everyone else. And we're saying that for all of these entities, what we have to do is we must specify details with regards to whether this person has read access, whether this entity has write access, or whether this entity has execute. Now I know what you're thinking, well, but Python execute doesn't start with X. Well, it's not me. I didn't design the Unix operating system. It was a bunch of smart people many years ago. And most of them are still alive, I guess, right? So RWX. So the owner has these 3 things associated with the file. The group also has these 3 things. So 3 plus 3 will give you 9, right? So in total, you have 9 placeholders that you're playing around with to specify permissions associated with that file, essentially. So just to kind of like showcase an example here, what you notice here is for this in this particular slide, this file called the swap file. You notice that by the way, the permissions here, we've clustered them out so that it makes a lot more sense, right? These would be the permissions here. Yeah, these would be the permissions here. And so we are saying that for each of these 3 entities, you're supposed to specify details with regards to reading, writing, and executing the file, right? So what we are saying in here is that the owner of this file is root, right? The root user. And we know this because in the previous slide here, we have root, right? So you know the owner is root has read and write access to the file. So the owner can read the file and he can actually write to the file, but they can't execute the file because there's this hyphen. The group, everybody else who's assigned the group root will not be given any permission. Everybody else on the operating system here, every other account that's been created on the operating system will not be given any other permissions, right? So this is what this means, right? RW hyphen all the way up to hyphen, right? Essentially. Any questions so far? No?
Sir,
Yes, sir.
is there an example of a swap file? Oh.
Yes, it's on your computer. It's just a file. I mean, that could have been that could have been anything else. I mean, it could have been any other type of file. It's just that I just happened to choose. I can't remember where the swap file is. Where is the swap file? Sorry. Where is swap file? Fine, you want to play hard to get, right? Locate swap file. There you go. So it's on the root, right? Here's the example of the swap file we wanted. Swap.
Yes. And another question, sir. Swap files embedded into the operating system, or they have to be made by the user?
They're not embedded in, what do you mean embedded in the operating system? They're created by default once you install your operating system.
Oh, right. That's
I didn't
what
have
I
to
was trying
create
to
this.
say.
Yes,
Yes,
this
that's
is
right.
created by the operating system. So if you install, if you did play, if you still have your virtual plans that you created as part of visit lab number 2 or some, I don't know if it's 3 or 1 or something, what you want to do is just do an ls and then try and see if you have the swap file. And just look at the size of your swap file, yeah? I do encourage you to do this so that you try and see if you want to play along with these things and try and, granted, this thing I'm talking about here could have been anything else, right? Could have been, we could have easily replaced this with ls, right? But we just thought this was a good enough, we could have replaced that file with ls. Where's ls? Bin, ls, right? We could have replaced this with ls so that instead of us having the swap file in the example, it's just an example in the slides, we could have just said, okay, it's this file we're working with, right? And you notice, I mean, everything else is pretty much the same. The only difference is the permissions associated with the file itself. And we kind of chose the swap file because that provides us with an interesting case where the permissions are only associated with the user, right? If you look at the ls command, for instance, observe, right? Everybody else on this, everyone on this system can read the file and execute it. You see this? It makes sense. This is a core. It's part of file management, right? ls, you're reading files, right? So everybody should be able to execute this binary. Everybody should be able to read it, right? Because obviously, I mean, you need read access for you to be able to execute it anyway. So, all right. Any other smart questions? I was going to start talking about the permissions, but we'll finish off the permissions, I guess. Is it tomorrow or day after tomorrow? And then we'll immediately transition into storage because we noticed last time talking about how the numbers are assigned can be a bit confusing. So we'll include a few examples. So we'll continue our conversation. I don't know if it's tomorrow or day after tomorrow. Unless if there are any questions, we'll stop here, I guess.
Dr. Lighton, with the case of the Unis file system, where we are saying that everything is perceived as a file. Now, do we have a different method of perceiving these? Like you have not mentioned how these same things can be perceived by other operating systems, or operating systems perceive things like devices. When you connect your devices to your computer, when they are mounted, they are all perceived as files even on different operating systems.
The short answer is I don't know. You'd have to look into the different operating systems. I don't know because I have not studied Windows extensively. See, there's something interesting about some operating systems, like if you look at Unix. Unix, if you remember our discussion of licensing associated with computer software, it's free and open source software. You know what that means? You have access to the source code. You have access to the documentation. There's nothing like this is trade secret, so we shall not tell the users how this works, right? It's difficult to study some of these things because they're proprietary. So the short answer is I don't know how they're perceived in these other operating systems. What would be interesting though is to look into this, right? If you're curious, you want to look into this. How many are there? I mean, Windows, what else is there besides Windows? Don't know, right? Windows Mobile, Windows 10, Windows Server, Windows NT, I don't know, right? But from the perspective of all Unix-like operating systems, yes, these rules apply. So your Mac OS, your Android OS, your Ubuntu, your Debian, your Red Hat, your FreeBSDs, they all conform to these things we're talking about here. Good questions. Good questions. Any other questions?
Also, so when we say that everything comes from the root, which is the base file system for Unix like operating systems. How is that an advantage for us having everything from one mount point, like from the root? How is that an advantage to the user?
Well, I don't know. I guess I could just speculate that file management is a lot easier, right? It's a lot easier for you to traverse the file system. It's a lot easier for you to write programs, right? I guess, I mean, these days, I mean, you could probably, I don't know how it's done in Windows, right? Imagine a situation where you're writing a program and then you have to specify the absolute path, right? Oh, it's D. Tomorrow is going to be E full colon. The other day is going to be F full colon, right? I don't know. I guess you could prompt the user to do that for you. But I don't know. I guess it's easier in terms of file management. But also, some of these things, it's just really more to do with convention, right? Some character a long time ago decided this was a smart move, and then everybody that comes along afterwards just follows suit, right? Like, I don't know, why don't we walk backwards? I don't know, right? Hey, I'll see you when you see me. I'm running out of battery power, as you can see. Thanks a lot. I shall share this as soon as my power is restored in this part of the world. Enjoy your fun and take care. Quiz on Friday. Quiz is from 10, 24-hour cycle, so 10 until 10 the following day. Thank you. Bye-bye.
Thank you very much. Oh, guys.